My name is Jennifer Dill. I'm a faculty member in the School of Urban Studies and Planning, and along with my colleagues, Chris Monsier, Rob Bertini, and Job Glebe, we help co-organize this weekly transportation seminar. And before I introduce our speaker, I do want to remind, because I think we do have quite a few new people here, we do webcast all of these seminars, so there are people watching on the web live, and that's one reason we're in this high-tech room, and part of this high-tech room are these microphones that are sitting in front of most of you. And so when you do ask questions, please use the microphone. And so basically you hold down where it says touch, keep the red light lit while you're asking the question so that people who are watching on the web, either live or archived in the future, can hear the question as well as our speaker's very insightful answer, I'm sure. So without further ado, I'm going to go ahead and introduce our speaker today, Jamie Parks. He is a transportation analyst with Kittleson and Associates, located here in Portland, or at least the office that he is with is here in Portland. And he's going to be talking today about some work that he did while he was a graduate student at Northwestern on quantifying and measuring walkability. And I'm going to turn it over to him to tell us a little more about himself and to proceed with the seminar.
Great. Thanks. As Jennifer said, my name... As Jennifer said, my name is Jamie Parks, and I currently work at Kittleson and Associates, which is a transportation consulting firm based here in Portland, but we do have offices around the country. And my primary interests are in ped and bike issues, and specifically safety, and I've also been involved in a number of transit projects, including looking at how to use onboard transit technology to better evaluate transit performance. So prior to starting at Kittleson, I got my bachelor's in history from Johns Hopkins University in Baltimore, and actually history is how I got interested in transportation. Took a couple of classes on urban history and realized what a large role transportation really has played in shaping the urban form, and that's what got me into it. And after that, I did my master's in transportation at Northwestern, which is where I conducted the bulk of the research that I'm going to be talking about today. And actually, how I got started in this research was I was working on a project for my research assistantship that was trying to measure the transit friendliness of about 25 different activity centers in the Chicago region. And one aspect of transit friendliness that we were trying to look at was the pedestrian friendliness. And it was my job to do this, and I asked what I was supposed to do for it, and sort of got some shoulder shrugs, and no one was quite sure what to do. And we didn't have budget to go out and walk around all these neighborhoods and do some detailed field surveys. So that's sort of how I got thinking about how we can do a better job of measuring it. So let's see. All right. So I guess throughout the presentation today, there are going to be a number of pictures mixed in with the slides that don't necessarily have to do with the specific slide, but they are all pictures of the neighborhoods that we walked around in Chicago. So they have some bearing on the presentation. So the first question that comes up when you start to talk about walkability is, why do you want to measure it? And first off, walking is important, and I guess there are two main reasons that walking is important. One is when you're walking, you're not driving, and when you're not driving, and reducing traffic has a number of benefits, as we all know. And secondly, walking is good for people's health, and we're currently facing an obesity epidemic in the United States. So to the extent that we can get people walking, we can improve public health. And we also know that the pedestrian environment is an important factor in whether people walk. There's a large body of research that's been conducted in the last 15 or 20 years in the transportation profession that's shown that a high-quality walking environment does lead to more walking. So it's important that we go out and measure it, but we need to figure out how to do that best. So there are a lot of measures out there right now that people have used, and they fall into two general categories. One, we have field survey measures, which require you to go out into the field, walk around, and give a neighborhood a rating. And the second are what we call laboratory or remote measures that typically, but not always, use GIS and usually look at measures of connectivity. So some of the major field surveys, the first two here were the Lutrac Pedestrian Environment Factor and the Maryland National Capital Parks and Planning Commission Pedestrian Friendliness Index. And that's the last time I'll say that acronym. in full. Those two I'm going to talk a lot more about later in the presentation because they played a large role in the research I conducted. And then the final two here are just really detailed studies that require a lot of effort to go out and implement. The Spaces was developed in Australia, and it's several pages of detailed questions. And then KISS is the Kid Street Scan, and that's out of, I think, the Delft Institute of Technology in the Netherlands. And that's 14 pages of really detailed information just to categorize one single street segment. So while that might be really good data to have, it's not something that's going to be practical when we're looking at a whole city or a whole region. So there have also been a number of GIS measures that people have come up with. So a couple of the more typical ones are census-block density, average block size, and intersection types. And both of these types of measures have some problems. The field ratings, one, they are subjective because you're asking people to make a rating. No matter how objective you try to make it, it is going to be somewhat subjective. And that brings up the issue of inter-rater reliability, because you want to know that if two different people go out and measure the same neighborhood, they're going to come up with the same result. And if you don't have that, then you don't know that your results are comparable between different cities or between different areas within a city if you have different people rating them. So that's one problem with the field ratings. They're also pretty time-consuming, and in general, PED projects don't have huge budgets, so we can't go out and spend all the budget collecting data. We need to spend some of the budget actually doing something. And finally, they're not applicable to proposed designs, meaning that if you require a field visit to give a neighborhood a walkability rating, you can't give a rating to a neighborhood that hasn't been built yet. Whereas if you have objective measures such as block size or intersection type, you can look at a plan on a piece of paper and determine what its walkability is going to be based on that index. And then as far as the lab measures that people have been using, they're good, but they're often one-dimensional. They focus on one aspect, such as census-block density or intersection type, and there's no real guarantee that that's the most important aspect of the pedestrian environment. And a lot of times for the GIS data, it requires data that's not available in all areas. I think Portland's pretty lucky to have a really great GIS database, but a lot of places in the country don't. So when we look at developing a walkability index, we want to have something that can be applied everywhere, not just in major cities. And finally, the lab measures aren't necessarily calibrated to actual measures of pedestrian activity or to even field measures of what the pedestrian environment's like. So there's been no real testing to say that intersection type or census block density is really the best way to measure pedestrian environment. You need something, so you use it, but we'd like to know that it's actually the best tool we have. So to start off with this research, we came up with several goals. So the first one is we want the measure to be completely objective, which that will ensure the inter-rater reliability if it's objective. We know that if two people measure the same neighborhood, they're going to get the exact same result. And secondly, it allows us to measure proposed designs. And we also want to control the data collection costs. And we don't want to have field visits because field visits are very expensive. And we also set a somewhat arbitrary deadline or a time of no more than 30 minutes per neighborhood. And this was arbitrary, but it did give us something to shoot for, to say that if it's taking longer than that, it's not going to be useful over a large area. And finally, we want something that can rely on widely available data. So this should be something that we can apply anywhere in the country, regardless of the amount of GIS data that they have available. So as far as what we did for the study, basically we collected two different sets of data for 23 neighborhoods in the Chicago region. So the first set of data were field ratings. So we used two different fairly accepted field ratings, the Pedestrian Environment Factor and the PFI. And we walked around each of these 23 neighborhoods with a group of observers and gave them a rating. And then secondly, we collected data on several variables several objective variables that could be collected remotely. and for each of those 23 neighborhoods as well. And then we did a multivariate linear regression to develop an index for each of those. So the field ratings served as the dependent variable, and we developed a different index for each of the field ratings. And then our various objective laboratory measures were used as the independent variables. All right. So to select the neighborhoods, I was in the Chicago region, so everything came out of Chicago. And we basically tried to select them to give the biggest mix that we could possibly get. So we have some that are in the inner city, some that are in the inner suburbs, which were primarily built before 1950 or so, and some that are in the outer suburbs, which have been built primarily in the last 30 years. And we have a mix of different types also. We have some entirely residential neighborhoods, some mostly commercial. We had one industrial. We did a commercial office park. So we tried to get as big a range as we possibly could within the constraint of only having 23 neighborhoods to choose from. So the first rating that we did in the field was the Pedestrian Environment Factor, which was developed here in Portland in the early 90s. And it's based on 4 variables. It's the ease of street crossings, the availability of sidewalks, the connectivity of the street network, and also topography. And each of these variables are given a rating from 1 to 3 by a group of observers. And in this rating, it's a fairly accepted rating in the field, and it's been proven to be strongly correlated with actual measures of walking, which is one reason that we used it. And because Chicago is very, very flat, we threw out topography in this case. So we had 3 variables instead, each of which were rated from 1 to 4. And then the second rating that we did was the PFI, which was developed in Montgomery County, Maryland, in the late 80s and early 90s, and like the Pedestrian Environment Factor, was used in some travel demand modeling out there and found to be significantly correlated with actual measures of people walking. And it's a little more detailed than the Pedestrian Environment Factor. It's based on a number of factors. And the rating goes from 0 to 1, with sidewalks accounting for 45%, land use mix for 25%, and then setbacks and transit stop conditions reach 10%. And there's also a component for bicycle infrastructure in the original PFI, which accounted for 10%, because it was actually used to look at pedestrian and bicycle trips. But because we were only looking at pedestrian trips in this study, we threw out the bicycle ratings, so our ratings went from 0 to 0.9 in this case. So to collect the field ratings, we used paid teams of either 3 or 4, and I used the term paid somewhat loosely. They were grad students, so the pay, I think, was a free lunch and $10, which was enough to get a few hungry grad students out walking around the suburbs for a whole day. And we walk around each of the neighborhoods for about 30 minutes. And actually, the picture here is actually relevant here, because this is the one neighborhood that we were stopped by the police for being pedestrians. We were in this fairly wealthy suburb with 150-foot setbacks and no sidewalks, so I think they hadn't seen a pedestrian in several years. And about 10 minutes after being there, the South Barrington police car rolled up and asked to know what we were doing out there. And needless to say, it didn't get a very good pedestrian rating from us in the end, which I think is reasonable. And then to get the overall neighborhood rating, we used the mean of the ratings that were developed. So this is a little different than the Pedestrian Environment Factor in Portland, where they sort of, I think, used what they called a modified Delphi approach, where the observers would get together and talk about the neighborhood afterward and come to a consensus. Whereas in this case, we didn't talk about the neighborhoods at all while we were rating them. Everyone could give their independent rating, and then we just used an average at the end. So the first thing that we wanted to look at before we used these measures in an actual model was, what is the actual reliability of the ratings? If we have our team of 3 or 4 people out there measuring a neighborhood, are they giving it the same rating? So we did some tests of inter-rater reliability, and this is, I think, actually an interesting result, somewhat independent of this research, because I don't know that the reliability of these ratings has been tested before. And what we found was that it's actually, the reliability is very good. If, we used the intra-class correlation coefficient to do this, and we found that when you have, and this is a rating that goes from 0 to 1, 1 being your rating is fully reliable. Everyone has the exact same rating. And we found that as long as we use at least 3 raters, we have a reliability of 0.95, which is pretty good. For most studies of this type, 0.7 is considered acceptable. So these are appropriate measures to be using as dependent variables in our regression as the actual measures of the pedestrian environment. So looking at the data that we collected for our 2 different measures, we can see that they ask different questions and they do come up with different results. So we have different distributions. The pedestrian environment factor, you're much more likely to score very well on because it's only asking a few things. So if you have sidewalks and you have a connected street network, you're pretty guaranteed of a decent rating at least. Whereas the PFI, it's pretty well or pretty evenly distributed across all the ranges. So here's another way to look at the differences between the ratings. Each of the columns represents one of the neighborhoods that we rated, and the length of the column represents the difference between the 2 ratings. So when you see a positive column, that means that the pedestrian environment factor was higher than the PFI, and a negative column is the opposite. So you can see that most of the ratings are fairly similar. If it's a good pedestrian environment based on one of the field measures, it's going to be pretty good on the other one also. But there are a few major differences. In one case, we've got in one case we have a very large difference, and in 3 or 4 cases we have a pretty large difference. In all of those, the pedestrian environment factor is scoring a lot higher than the PFI, as we'd expect from the distributions. So to get on to what we did for our laboratory measures, we looked at a total of 8 different ratings, or 8 different variables. So 5 of these variables we collected using GIS, and we collected for the neighborhood as a whole. So these ratings, we use Census GIS files, which are available for every county in the United States, free of charge and easy to download on the web. So they satisfy the criteria of being widely available data. And in these 5, we looked at the average block length, and then we also looked at the standard deviation of block length, thinking that average block length can be a little deceptive because if you have some very short blocks and some very long blocks, your average may be okay, but those very long blocks can disproportionately affect the quality of the environment. And then we also looked at intersection type, and we looked at both the ratio of 4-way intersections to all intersections. And when I say 4-way intersection, I'm also including anything that has more than 4 legs, because we're not concerned that we have a Cartesian grid, just that we have a connected network. So we looked at both the ratio of 4-way intersections to all intersections, and then we also looked at the density of 4-way intersections. So there's sort of 2 similar but somewhat different ways to look at it, and we looked at the effects of using both of those. And then the final measure that we calculated with the census data was the census-block density for each of the neighborhoods. So the census-block density is really another measure of the connectivity of the street network. So then we also collected three different measures for only a sample of the blocks in each neighborhood. So these were measures that we didn't have GIS data available for. We had to collect off of aerial photos. So collecting for every single block in the neighborhood, we decided that would violate our goal of making the rating take 30 minutes or less. So we looked at some ways to just take a sample of blocks from each neighborhood and use those and hope that the sample is a good representation of the neighborhood as a whole. So these 3, we looked at the sidewalk provision, and this is something that's often available in GIS. So if you have it in GIS, you can easily automate this and not go through the aerial process. But when it's not available, looking at the aerial photos can work almost as well. So this is a rating that runs from 0 to 2, 2 being sidewalks on both sides of the street, 0 being no sidewalks, and 1 would be a sidewalk on one side of the street. And then we also did the average building setback, which we calculated just from either the edge of the road or the edge of the sidewalk. If there was no sidewalk, we did the edge of the roadway to the front of the building. And if there was a sidewalk, we did the edge of the sidewalk. So essentially the edge of the walking way to the front of the building. And we thought setback would be important because it's, one, a measure of accessibility for pedestrians. And also, neighborhoods with lower setbacks are often more visually interesting to pedestrians and more aesthetically appealing. So it has multiple reasons that we think it's associated with good walkability. And finally, we looked at what we call the adjacent parking ratio. So this is similar to the sidewalk ratio in that it runs from 0 to 2. 2 would mean that your sidewalk or roadway is paralleled by a parking lot on both sides everywhere, which doesn't happen too often, luckily. And then 0 would be no parking lots along the sidewalk. And we thought that this would be a good measure of the pedestrian environment for similar reasons as the setback. Because if there's a parking lot next to you, you're going to have to cross it to get to your destination. So buildings aren't very accessible. And parking lots aren't very visually interesting to look at. And finally, parking lots are associated typically with a lot of driveways. And driveways are, can be hazardous, and they're not fun to cross, a lot of them. So we thought that this parking ratio would be a little bit of a proxy for the number of curb cuts along this sidewalk. So as I said before, we wanted to figure out a sample of blocks that we could take for these neighborhoods that would work all right. And the goal here wasn't to find the statistically correct sample size. We wanted to find a sample size that would work adequately for our problem here. So we looked at a few different sample sizes, and you can see in the graph here, I'm showing how the sample sizes, how different sample sizes compare to the actual results. So when you only have a sample of five block faces for a whole neighborhood, you're seeing a lot of variation. There's really no guarantee that what you're seeing in those 5 blocks is representative of the neighborhood as a whole. But when we get to up to 20 blocks, we're finding that the variation's pretty small, and we're still satisfying our goal of 30 minutes or less. So we settled on a sample size of 20 blocks. So this might be changed, and we might want to look at how this could be altered in future research. So to give you an example of how the data collection from the aerial photos worked, I'm not sure how well you can see this, but the yellow lines on the map here represent the 20 blocks from the neighborhood of Wilmette, which is north of Chicago, that were sampled. And the picture to the left zooms in on one of the blocks in particular. So to calculate the 3 variables that we have, sidewalks, you'd measure the number of feet of sidewalks that we have, and the feet of roadway for that block. In this case, you have sidewalks on both sides, so that ratio is going to be 2. And you would also, using GIS, because these were, I should have said this earlier, these were digital aerial photos, so we could bring them into GIS and measure distances. So we measure the distance for the average setback for the buildings, and then if you see there's no adjacent parking, so that would be coded as 0. So to summarize the data collection for the lab measures, we got a pretty wide variety. I mean, we've got a good mix for each of, or a good range for each of the variables that we looked at. So we were happy, and this, this should work well for developing an index because we do have a lot of variation. So here's some of the correlations between the measures, and don't want to go into this in too much detail. The main thing to look at are the first 2 rows, which show the correlations between each of the variables and the field measures, or between each of the field measures and the 8 variables that we looked at. So you can see that in general, the correlations are very high. Most of them are greater than 0.8, a few more than 0.9, and they're all in the in the correct direction, meaning that if we expect a positive correlation between a particular variable and the field measure, we're seeing a positive correlation. And the one exception that stands out is parking ratio, which I'll talk a little bit more about in a minute, but the correlation here didn't work out well at all, so we didn't use it for our indexes. And finally, in the bottom rows show the correlation between the variables themselves, and as we'd expect, there's a lot of collinearity here. The variables are interrelated, so that's just something to watch out for when we're developing the index. So it's a little more on the parking ratio. So the reason that we found that the parking ratio didn't work out well was for a lot of the suburban residential areas that scored very poorly on the pedestrian measures, there were almost no parking lots at all. But they still scored very poorly. On the other hand, if you look at just the commercial areas, then the parking ratio does turn out to have a pretty high correlation with what we're seeing in the field. So unfortunately, we didn't have enough data to incorporate this segmentation into our model development, but I think this might be another result that could be built on in further research. So for the regression analysis, we took each of the field measures separately. So we did different regression indexes for each of those field measures, and we tested many different combinations of the variables, and we compared them on several standard goodness of fit measures, the R-squared, t-values for the individual variables, and did f-tests where that was appropriate. And we finally selected a preferred model for each of the rating systems. So here's a summary of a few of the regression models that we calibrated for the PFI data. And the one on the far left is the one that or I guess it's the far right for you, sorry, is the one that we ultimately selected. And you can see that the R-squared values for these are all pretty high. And the one that the preferred model in particular, the R-squared is over 0.93, which indicates that we're capturing most of the variation between the field measures in our model. So we're pretty happy with this. And let's see, so I guess a few things to note is one, we did find that the standard deviation of block length worked better than the average block length for our ratings, both in the models and because we also had some theoretical reason to believe this would be true, given that the mix of very short and very long blocks we don't think is very pedestrian friendly. We did incorporate that into our preferred model. And also another thing to note is that instead of using just setback, we used the inverse of setback for all of our models. And this performed better, and also it makes sense given that we expect diminishing results from increasing setbacks. Increasing the setback from 10 feet to 20 feet is pretty significant, but when you increase it from 100 feet to 110 feet, that's probably not very meaningful. So we did use the inverse of setback. And here's a similar comparison of several models for the pedestrian environment factor. And we do find that different variables result in the best model here, but like the PFI, we are getting some really good goodness of fit measures. The R-squared value, again, is over 0.93. And as you can see, there's several models that work pretty well, but we did settle on a preferred one in the end. So finally, you can see the indexes that we came up with ultimately. So for the PFI rating, we have the standard deviation of block length, census-block density, four-way intersection ratio, sidewalks, and the inverse of setback. And not only does this have a high R-squared rating, but we're also seeing that the coefficients on each of these variables are in the sign that we would expect. When if you expect a positive correlation, you're seeing that in the sign of the coefficient. And for the pedestrian environment factor, we have only 3 variables, which is the four-way intersection ratio, sidewalks, and the setback. And once again, a pretty high R-squared value. So I think I've really covered this slide already, basically, but we were in the end, we were very happy. I think a little bit surprised by how good the models came out and how much variation they were capturing. So I think basically the models that we developed are pretty much as good as the field ratings on which they're based. So if you accept that the field rating is a good way to measure the pedestrian environment, then you could also accept that these models that use objective data and don't require a field visit are also a good way to measure the pedestrian environment. So here, just a scatter plot that shows you how well the model performs, and you can see that in general for each of the neighborhoods we're pretty close with our model. There's nowhere where the model is giving us something that's way different than the pedestrian friendliness index. And similarly for the pedestrian environment factor, we see a scatter plot where most of the variation is taken care of by the model. And this is what we'd expect when you have such a high R-squared value. So say a few words about implementation. And this was pretty exciting for me. It only happened, I guess, 2 or 3 weeks ago. I finally got to use this model in practice, so it was pretty exciting. We're doing a pedestrian master plan for Fort Myers, Florida. And as part of the existing conditions analysis, we wanted to evaluate the pedestrian environment throughout the city. And our budget for this project was not large. We didn't have money to fly down there and walk around each of the neighborhoods and score them. But we were able to use this index to come up with a friendliness index for the whole city. Basically what we're seeing here is I divided the city into quarter-mile by quarter-mile blocks and calculated the preferred PFI index for each of the blocks. And in this case, everything was fully automated in GIS. So because the city did have a sidewalk database, there was not a way to automate the setbacks. So we were forced to eliminate setbacks from the model. We just used an average for every neighborhood. But we are seeing some good variation, and we're seeing what we expect to see, I think, here, in that the downtown gridded area is scoring a lot better than the more recently developed suburban areas that have really poor connectivity. And all in all, this took about 5 or 6 hours for me to calculate, which compared to going and walking around Fort Myers was a big benefit. And I think one thing that this showed was that our goal of 30 minutes per neighborhood, even that's a lot when it comes to measuring a whole city. So I think here we weren't even able to apply the aerial method because we didn't have that much time. Even if we're taking only a sample of block bases, that was still too much effort. So I think this really points to the need to develop GIS data so that we can automate these tasks and make them more applicable. So the conclusions are that, one, the models are basically as accurate as the field ratings to which they're fitted. So as I said before, if you're accepting that the field ratings are good measures of the pedestrian environment, and they have been, they are proven to be strongly correlated with measures of walking, then these models that we've developed are equally good, and they have the benefit that you can do them in your office, and they use objective data so that that the results are comparable over different areas. The models satisfy the goals that we laid out and that they're objective, and we don't require any field visits. So I can say a few words to finish up about what I think would be good for future steps to measure the pedestrian environment. So one, more and better GIS data, because as that becomes available, you can increase the number of variables that we're using. So I think Portland's probably on the leading front of this, but to the extent that you have sidewalk widths and buffer distances and maybe stuff on street trees and benches, those are things that once you have them in GIS, we can easily incorporate them into future models. And secondly, I think it would be really important to incorporate traffic counts somehow into these measures, because one of the really primary things that affects the the walkability of an area is how many cars it has in it. And that's something that's not captured in this model, or really many that I've previously seen. So to the extent that we can figure out a way to to incorporate traffic data into the models, I think that would be really good. And finally, I think in the end it would be beneficial to develop link level in addition to neighborhood level measures, because neighborhood level measures are good for modeling purposes. If you want to know, if you have to break things out into traffic analysis zones, you may want a neighborhood level measure. But typically, any improvements that we're going to be doing are really going to be focused on the link level. So the neighborhood level measures, they might help us zero in on a few neighborhoods, but you're still going to need to do detailed analysis of those neighborhoods to figure out what links and what specific areas need the improvements. So if we could incorporate that directly into the measures, I think that would be really good. So I'll close here with a picture of a very walkable Chicago neighborhood in Wrigleyville, and I'll take any questions that you have. Okay.
This might just be a question about the GIS data, but I was wondering, when you were developing your model structure, if you considered using variables like neighborhood proximity to, say, parks or green spaces or grocery stores, schools, things more like end destinations that people might be walking to.
Yeah, I think we did look at that a little bit, and we tried to incorporate some land use data from the Chicago area MPO at the time. But the problem with that data was it was far too aggregate. And since that time, I mean, this research was conducted about 2 years ago, which isn't that far ago. But since that time, Google Maps and Yahoo Maps has really improved. So at the time we were doing this, you couldn't find really widely available data on grocery stores and schools and parks like you can now. So I think certainly something we would look at, but we weren't able to at the time.
Were there any surprising trends that you noticed through your PFI and your PAF going from inner city to, say, suburban areas?
Yeah, I mean, in general, I think the area, we were using field measures that use subjective ratings of the pedestrian environment. So in general, what I thought the pedestrian environment would be like was what it ended up being like, which is maybe partially a result of using subjective ratings. And I wouldn't say any real surprises. The inner city neighborhoods scored a lot better. I think in one case we did do one of the poorer neighborhoods in Chicago where many of the buildings had been bulldozed because they were vacant, and that neighborhood consequently had some very large average setbacks, even though it was originally built with almost zero setbacks. So that did affect its rating. So that was maybe one interesting thing.
Do you have thoughts on the use of neighborhood boundaries to calculate your PFI index versus like a grid?
Yeah, so I think for the research, I mean, we used a 2,000-foot radius from a center point, and these were just idealized neighborhoods. So the rating could be applied into any shape that you wanted to do it. So the size of the neighborhood would really be up to you when you're applying the index. I guess the biggest concern is just you can't make it too big. Each neighborhood has to be relatively homogeneous to get a good rating.
Did you break up the neighborhoods as far as zoning at all, or was it just kind of what you guys thought needed to be broken up wherever?
I guess, so when we came up with our 23 neighborhoods, the goal was, it's a little bit different than something you would actually implement, because our goal was to find 23 neighborhoods that were as different as possible and as homogeneous as possible. So it was somewhat a subjective task, but we basically went through the Chicago area on the map and knowing what we knew about the different areas and picked out specific neighborhoods that we thought represented homogeneous areas that represented each of the different facets we were looking for. And because we wanted each of them to be the same for the purpose of the research, we just used a 2,000-foot radius. But I think for implementation purposes, I think zoning would be a good way to break them up.
A big subject for pedestrian environments are, marked versus unmarked crossings, and when does marking a crossing really benefit safety or not? Do you think that some of these measures can help in terms of determining when you might be in a marginal location about whether or not marking a crosswalk would be a safety enhancement or not?
I think this particular measure is a little too aggregate to pinpoint a specific location for a crosswalk. I think that's where I talked about incorporating traffic counts at some point and more GIS data. So I think to pinpoint marked and unmarked crosswalk locations, you're really going to need to have detailed data on maybe curb extensions and sidewalk widths, and also the traffic count data that we weren't able to incorporate here, but at some point in the future, I think we could develop objective ways to categorize this.
I was wondering if you assign different weights for each of the individual variables within the multivariate analysis per different city that you're accessing?
Well, yes, I think the coefficients for the analysis were sort of, they're optimized in the regression analysis, and we did. All of our neighborhoods were only for Chicago when we calibrated it. So, to the extent that there may be differences between cities, we're not going to capture that. I think it'd be interesting research to see if that there's change between different cities. But hopefully, a good pedestrian environment is a good pedestrian environment anywhere. That was our assumption anyway. Mm-hmm.
So following from the first question, are you aware of any other studies or maybe any other applications, like you mentioned Google Maps and Yahoo Maps, that do incorporate sort of accessibility, more of a measure of accessibility to goods and services locally, as well as walkability, rather than just the walkability of the neighborhood?
I mean, there are some measures that have been developed, such as, if you're familiar with land use entropy measures, where people have tried to incorporate land use data to determine a precise mix of neighborhoods. And we looked into them a little bit, and the land use data we had was a little too aggregate to use, and some of the entropy measures also I don't like too much, because if you mix a grocery store with housing, that's good land use mix. But if you're mixing industrial land with vacant land, you're probably not helping anything, but that's often showing up the same way in your entropy index. Jennifer?
I actually have some questions from the web,
right,
several,
sure.
but I'll just throw out one for now. One question was, are sidewalks absolute prerequisites for good walkability? And the person asking the question is, your wealthy suburb image without the sidewalks looked perfectly nice place for me to walk. The huge setbacks perfectly fine. He thought that the real issue might be traffic volume on the street rather than sidewalk availability.
Yeah, I think certainly traffic volume determines the necessity of having a sidewalk. If you have no traffic, then people can use the street, and there's no problem at all. But I don't think it doesn't take very much traffic before sidewalks really become useful. I mean, I live in southeast Portland on a local street that only has a couple hundred vehicles a day, but I still always walk on the sidewalk, and I prefer not to walk on the road. So in general, I think we could incorporate traffic data into the sidewalk measure to determine when it's absolutely necessary to have it, but we weren't able to in this case.
My question was about the parking ratio. I know you struggled a little bit getting that to work right, and I was wondering about how you dealt with on-street parking. My understanding of it was that the more parking there was, the less favorable it was as a pedestrian environment. But on-street parking on a busy street can really enhance a pedestrian environment. So how did you handle that?
Well, the specific ratio that we measured was for off-street parking. So our measure didn't incorporate on-street parking. So I think that looking at on-street parking would have been an interesting thing that we actually didn't look at. Trying to get that off of aerial photos may in some cases be difficult, to tell whether a car is parked or driving down the lane. So I think So for our particular implementation, it wasn't going to work out because of our reliance on aerial photos, but in general, I would love to see on-street parking or other buffer measures incorporated into a measure. Chris?
You mentioned that you came to this question starting from transit friendliness and assessing pedestrian friendliness. Have you looked the other way to see if the presence of transit, particularly what I'll call amenity transit like streetcars, enhances the walkability of a neighborhood?
It's an interesting question. No, we didn't, actually. And once again, I'm not sure that, I guess my personal opinion would be that it doesn't actually improve the pedestrian environment. It improves your pedestrian accessibility, but it may not actually improve your environment. It'd be something to look into, I think, but we didn't incorporate it here. Actually, and in Chicago, the amenity transit is the L, which is, it's great for getting around, but as far as what it does to the streetscape, it's not particularly pleasant. Sure.
I've been working with public health research for a while, and it does appear that there's a very strong correlation between presence of transit on the demand side, so that it does actually create pedestrian traffic. And
right.
So, and again, the other dimension of the demand side has a lot to do with other amenities like commercial properties. But
transit might increase demand, but it may not actually improve the walkability.
Another web question.
All right.
And the question deals with how you would see local governments using this model in land use planning or development. How might it be applied?
Well, I think one obvious area, or the area that I was thinking about most when I did it, was for travel demand modeling. I think that, right now we don't do a very good job in most places of measuring pedestrian trips at all in our demand models, and capturing the pedestrian environment would be a good way to do that. And I think that what we did here in Fort Myers is a useful example also of what a local government can do. I mean, this didn't take a huge amount of time to implement, and it does give some idea of, we have, it's a little difficult to tell here, but we do have schools marked on here, so it's not difficult to go in and mark all the schools that are located in below a certain rating, and then maybe you go to those schools and look at them in some real detail to figure out what needs to be done to improve them. So I think I think there are some useful applications that local governments could use.
I'm curious if you could, what your sort of wish list is in terms of the link level measures and how you see those relating to these more aggregate ones, because each link does have to participate in an area. So I'm wondering.
Yeah, that's probably not a fully formed desire. I think it really came apart as part of this study, which I created this map about 2 weeks ago, and we haven't actually submitted our report yet, identifying priorities. So I've been thinking about how I'd actually do that, and I decided I would like some link level measures, but I don't have concrete answers on exactly what they would look like.
Okay, well, you talked about how your model has a good fit with the field ratings and allows you to do these other extrapolations. I wonder, in terms of, you said that we have to take for granted that the field ratings have a good correlation between these things and walkability. And I wonder, is there data on, like the walkability, or how many people are actually walking in different places to compare, like, your model versus you have a place that has all the characteristics of a good walkable environment and nobody's walking?
Yeah, so in general, data on pedestrian travel is sparse, and most of it comes from region-wide household travel surveys. And the two field measures that we looked at here were calibrated versus region-wide household travel survey data to figure out if they were correlated with walking. But certainly, it'd be a much larger research topic, but it'd be very interesting to incorporate, to play around with some demand modeling using those regional models to figure out, if this index works as well as the field measures did, and actually correlating with the walking measures.
Flooded with web questions.
Wow.
We have several students and other people out there watching. So one of the questions, one of our watchers, viewers, was wondering, wants you to discuss a little bit the potential for bias. In other words, is what we're measuring in the field and in the lab really, how might it be influenced by the investigator's bias as to what is pedestrian friendly?
Well, so the lab measures aren't influenced at all by bias, but when they're incorporated into the model, they do, they add whatever bias is in the field measures get thrown onto the lab measures, and it is, it's something we struggled with throughout this. Was we wanted to have something that wasn't subjective, but in the end, I think the pedestrian environment is somewhat subjective, so it's really difficult to fully pull yourself away from subjectivity. And at some point, we had to tie our variables to something, and the fact that they are a little bit subjective is a problem. And if there are other, but I think what this shows is that if you have another field measure that you're really gung-ho about and you think is really important, then you could probably duplicate this effort and come up with an index for that field measure that would work as well as actually going out into the field.
And I'll sort of continuing on, and another question melding in. I mean, while there may not be any bias in the the average setback, there is perhaps some bias in initially choosing what to use. You chose to use sidewalks and setback and parking, and so that leads me to someone else's question, which was in my mind as well. And what about using street width? Because the width of the street, like either the number of lanes or the absolute width, would give some indication objectively about ease of crossing and traffic volume as well.
Yeah, I would like to use street width. I don't know. That would be an interesting one to incorporate, I think. And it is something that would work for the aerial photos also. And could probably give us some interesting things. It would be interesting to figure out how you average street width over an entire neighborhood. If you have one 8-lane arterial and a bunch of skinny local streets, how does that balance out, and what's the proper balance there? In the back?
I think you hit the parking problem there, too, very quickly, because 39th Avenue is the same width as many of our 2-lane streets that have parking on them. Mm-hmm. So without an ability to determine the presence or absence of on-street parking, I think that despite the attractiveness of using the street width, would be a big issue.
Yeah. Yeah, that's a good point, because there's 39th is 40 feet curb to curb?
Something like that.
Yeah. Yeah, so that's interesting. Do cities have data on where on-street parking is located and where it's not?
We do.
Yeah.
The City of Portland does.
Okay.
I wonder about the density, if you could do something with the density of the vehicles on the aerial, because there might be. I mean, obviously there's huge number of masters projects cropping up here.
Yeah.
So hopefully we'll get some activity from inside the room here.
Yeah, I think the density of vehicles, I mean, you have no idea when the aerial was taken, so that's a real problem. I mean, if you're comparing two different areas, one the aerial was taken at rush hour and the other at 7 a.m., it's hard to make a fair comparison. Yeah.
Could you use your data to use like a whole street, say 39th or Sandy, as opposed to breaking it up for neighborhoods? Would it function that way in that you're using your idea of the link on a corridor?
I think you could. In general, the field measures were designed for a neighborhood. So if you have land use, so if the field measures incorporate like land use mix or setbacks, I guess especially land use mix. If you may be walking down the street and you may have 10 grocery stores 200 feet away from you on another street, so it would be difficult in that sense. But to the extent that the measures in the field measures are really focused on a link, then I think that the variables could also be focused on a link. In the back?
So I wonder, another methodological question, I wonder to what extent spatial autocorrelation may play a role in some of the sampling of sites that you did in those 3 measures, and if you did consider that at all?
Well, the way we sampled the streets was, the likelihood of being chosen was proportional to the length of the block segment, figuring that, the role that a particular block plays in a neighborhood is also proportional to its actual length. So sort of added up the total length of roadways in the neighborhood and then chose at random from that. And I don't know if that answers your question or not. Yeah.
It seems like a lot of people are getting at the question of like the function of the street and how pedestrian friendly it is to be on it. I was wondering if you looked at, they talked about width of street, on-street parking, whether you cleaned the streets that you looked at in your data set by whether it was an arterial, a freeway ramp, because in the GIS sometimes it's hard to clean that stuff out before you ask your question.
So we did eliminate all freeways and freeway ramps from the data, so they couldn't be chosen because pedestrians aren't allowed on them. Other than that, everything was chosen randomly, and I think that gets into the sample size question, and that's why, sampling 5 blocks didn't really work at all because make it all 5 local streets or all 5 arterials. But we did find that once we got up to 20, actually, I'm not sure how well I explained what we did for the sampling. So for 5 of the neighborhoods, we did take a census. We looked at the aerials for every single segment on that street, and then we compared different samples to what the actual rating was. So we did know what the actual measures for those neighborhoods were for 5 of them, and compared the different sample sizes. So we found that we didn't have too much variation when we got up to 20, but there's certainly the possibility that you're going to end up with a strange sample.
I had a question about the implementation and of a map like this, and that you could be able to isolate individual features such as lack of sidewalks and identify areas around the city which could have policies directed to make them more walkable. For some areas like the South Barrington you talked about, you can put sidewalks in, but it's not really going to do much. And so you figure out areas which could be targeted, which have a good chance of becoming more walkable.
Yeah, I think when you're actually talking about implementation, you need to look at 2 things. One is the actual friendliness of the area, and then the other is how many destinations you have. So if you have a place that has a lot of pedestrian destinations but really low friendliness, that's probably your highest priority. But a place like South Barrington, it's not pedestrian friendly, but there are not a lot of pedestrian attractions either, so it's probably low on your priority list. So you have to combine maybe this data with some data on population density or percent of households without cars or something that would give you an idea of of where the real pedestrian attractors are, and then so this can't be a standalone. It has to be combined with other things.
Sort of going along with that question, what would you think about factoring in like more social data, like maybe neighborhood crime statistics or something like that?
I think it's interesting. I think crime data and crash data would be 2 different data sets that may be useful to try to incorporate it. And I think in general this measure or these measures are designed so that you can do them for all over the place where you don't have crime data, or they're using data that's widely available. But I think you could overlay crime data on top of it, or crash data on top of this map, and isolate areas that have high crash rates, or high crime, and are scoring poorly. Or if you were in a city that had really good crime data and you wanted to incorporate it into a measure, you could recalibrate this.
Where do you rate urban form in terms of other aspects of increasing walkability?
I would rate it personally very highly. I don't think that we had a way to measure it really adequately in this study. I mean, we have setbacks, but if you're 2 feet setback from a blank wall, that's probably not helping you. And if you're 50 feet setback, but you have some sort of park there, that's probably beneficial to your walkability. And I think urban form is very important to how pedestrian friendly an area is. And I think it'd be nice to better incorporate urban form into these measures.
Well, what I'm asking is I'm sure it's all important to pedestrian friendliness, but in terms of how much people actually walk, in terms of other factors you can think of a lot of other countries that probably have none of these features and have a lot of people walking as compared to ours. So, what other factors do you think would be?
Well, I think the other factors are destinations. And destinations, and then when you mention other countries, I think auto ownership plays a huge role. If people have no other way to get somewhere, then they're obviously walking no matter how friendly it is. And you still may want to improve your walkability, but you have to realize that people are going to be out there walking if they have no other options either way.
I'm not sure if I missed this, but did you calibrate your modeling to actual pedestrian volumes on the roadway?
No, we didn't have pedestrian volumes. We did it, I guess, by sort of transitively. So the field measures were shown to be correlated with actual pedestrian volume. So we knew that, and then we correlated our measures to the field measures, but we didn't directly have any access to pedestrian volumes. General pedestrian volume data is really difficult to get at.
Did you include or take into account bridges and other off-street paths?
Actually, that's one thing I meant to mention. We didn't for this measure because we used the census tiger line geographies, which in general don't include off-street paths. So, you can see this is a pedestrian-only street here that I think most of us would agree improves or is really walkable, and it's not going to show up on this rating. Now, if you have data on where your off-street paths or pedestrian-only streets are, you could certainly just join that to your road file, and any off-street path would count the same as a street. I think you could incorporate it, but that is one problem with this measure, and it's maybe mostly a problem with the census data that we're using for our road file.
Well, I want to thank our speaker. Before we thank our speaker formally, next week, happy Thanksgiving to everyone. We won't be here on Friday. The week after, we have a speaker from Washington State Department of Transportation talking about interchange design. So thank you very much.
Thanks.